Most students will need to do a multi-pass T-joint with 7018, and so I put this video together with students in mind. Let's do it. 7018s usually run pretty good at 1 amp per 1/1000th of electrode diameter. So a 1/8 is 125 thousandths, which would be 125 amps. But all brands run a little bit differently, so I'm running at 130 today. Electrode angle is important too. Just a slight drag angle is probably what I'm going to try to use. You can use more of an angle. You can almost go straight in as long as you hold a good tight arc. The tight arc is very important. I'm going to try to use an angle like this for most of it, but on the top or last beads, I'll kick it down like this to avoid undercut. Here we go. You might notice you can see a little bit of a yellow turbo fan in the background there. A fan is a great idea. If you position your fan correctly, you can get rid of the smoke out of your breathing zone. If your school has a fume extractor, snorkel hood type thing, definitely pull that thing down and suck those fumes away from you. Okay, so I'm just holding a tight arc, and what I mean by a tight arc is that I can almost feel the flux that's baked on the outside of that rod. I can almost feel it scrubbing here and there on the base metal. I'm not trying to jam it in there deep. I'm just kind of gently letting the metal kind of hold a little bit of the weight. Trying to hold my arm still and not shake all around. I did not clean any of the mill scale off for this particular little skill exercise. It is best practice. It will weld a little bit better, but for the sake of training, I just think it's wise to just spend your time welding. When you get on groove welds and bend tests and things like that, definitely clean the mill scale. Practicing restarts is something that pays big dividends. I used a 12-inch long T-joint today just for that reason, so I would have to do a few restarts. So let's look at a restart here real quick. There's the crater where I stopped. I like to strike the arc right in front of that, long arc it a little bit, and then take it right into that crater, and then take off and weld over top of all the arc strikes and crud that I just laid down. Whatever method you use for a restart, you just don't want to have arc strikes outside of the weld zone. You want to weld back over top of any arc strike. Now it's time to stack a second bead on the bottom half of that bead. This is my rod angle for that. I'm pointing a little bit more toward the bottom member. And I'm not exactly going to stack it exactly halfway, more like 2/3 of the way over top of that first bead. I'm kind of lining the top edge of that bead up with the toe of the previous weld and trying to keep that little spacing, the edge of my bead, you know, an even distance from the toe of that previous weld. Now, this is sped up a little bit, but I mentioned earlier that arc angle or electrode angle is very forgiving as long as you keep a tight arc. You can see I'm almost going straight in and then maybe even a slight push, which is not recommended, but if you got enough amperage and things are going well, again, the electrode angle can be very forgiving. I chose a short rod because I've only got a short distance to go to finish this run, and I'm propped up here a lot more rigid than I would be with just holding it with one hand because I don't want to leave any arc strikes outside the weld zone. Alright, last bead. Rod angle is just a little bit different. I'm using a slight drag angle, but I'm angled definitely more horizontal, pointing the electrode into the top member a lot more to avoid undercut. And I'm trying to just go along at a nice steady pace, not get carried away with rod angle, a slight drag angle, keeping my arc length good and tight. Things are going pretty well. I'm trying to eyeball the bottom edge of that bead and keep it the same distance from the toe of that bottom weld. And I'm not doing any distinct electrode manipulation or anything, or any circles or anything like that. If I do them super tiny, just in my mind I'm doing them, and you can't really even tell. Alright, one little bit more, and we'll be done. We're going to do a cut and etch here in just a minute when we're finished with this thing and it cools off. Get a look at it, see how we did. Cut and etch will tell us if we got penetration into the root, or if we got any voids in between beads, or if we got any undercut or low spots. So let's speed the rest of this up so we can get to the cut and etch. Okay, let's knock that slag off there, give it a wire brushing, and take a look at it. The great thing about a cut and etch test is while the puddle is still fresh in your mind, you can kind of correlate what you see as far as how deeply everything penetrated or didn't penetrate. And then you can make adjustments to either your procedure, your amperage, or your technique, or something. Or you just show yourself that you don't need to change much and everything worked out okay. Either way, one test beats 100 opinions. Well, thanks for watching. My online store is at weldmonger.com. I appreciate your support.